Hi guys, welcome back. Today we're going to start talking about algebra from the very beginning. And when I do that, I like to connect back to some material that you already know, arithmetic. So that's what we're going to do. And you'll notice up here on the board I have 2 apples and I have 3 apples, because more than likely when you were in kindergarten and first grade, that is the way you first started learning to add. And it was fun back then. It really was fun. At least I remember when I did it, and it was fun. Because we got to actually color these red and put green stems and so forth. And we got to actually eat them and count them and touch them. Because we were learning as little children what addition really meant. And we had to touch them first before we could grasp that. So let's see what we learned back then. We learned that if we had 2 apples and then we added 3 more apples to that we would have 5. And then our teacher said to us, probably 5 what? Well, apples, of course. So we would have 5 apples. So we got to draw them again. We got to do that fun part. So we had an apple, another one, and we got 4 of them, and we had 5 of them. And our answer wasn't just 5, but our answer was 5 apples. And then your teacher talked to you probably about what would happen if you tried to add 2 apples and 3 oranges. And then we had some jokes about, well, we could get 5 fruits. But really, the bottom line was that we couldn't add apples and oranges because they aren't the same thing. So let's take a leap from that which you already know so well to really what algebra is talking about. The difference in algebra and arithmetic begins with replacing those apples with something we call a variable, which is like a letter, and it could stand for anything. Might be apples, but it really could just be anything. So let's do it with x. And your same problem would look like this. 2x, 3x, and you would add that up, and I would let you guess, and I know you would get it right, and you would say 5x, and you would be perfectly right. In algebra, usually we write it this way. We write 2x plus 3x, and then we answer to 5x. And we usually write it this way rather than up and down, but it really doesn't matter. So let's just practice a couple more of those, remembering that the main idea is that we can add those things which are alike and only those things which are alike. So let's do some of those. Let's take this one. Suppose we've got 4a plus 2a, which we already would know is 6a. Now let's add another a. And this time there is no number in front of a. There's nothing we see there. But when there is no number appearing in front of a letter or a variable, we understand that, and then later we assume that to be 1. So some people like to actually write a 1. Some people never write a 1. You will see it both ways. But let's add this up. We've got 4 a's and 2 a's, that's 6 a's. We've got 1 more a, and that's 7 a. And again, the reason that we can add those up is because they are alike. They are the same thing. We call that in algebra like terms. You'll hear me say that so many times. Let me write it for you. L-I-K-E-T-E-R-M-S. And that is like terms. And it just means that I'm not trying to add apples and oranges. Another example, a little more complicated, would be 3xy plus 4xy plus 2xy. We're like, okay, still everything is the same. Every single term is an xy. So we're just going to get some xy's. So how many are we going to get? Go ahead and guess. We're going to get 3 and 4, that'd be 7, and 2 more, and you get your guess going. And so I bet you guessed 9xy. I mean, what else could we get? We're adding a bunch of xy's together, so we get 9xy. Sometimes it's a little trickier looking, like maybe 3x plus 2y plus 5x plus 4x plus y. And I say it's trickier, but it's not really trickier. It's just that it's not lined up exactly perfectly. And I've got two different things going on. I've got some x's and some y's, and they're not the same. So let's see what we've got. We've got 3 x's, and then we've got 5 more x's. So we add those together because they are alike. And so that means that we have 8 x's. And then we look at what else do we have? Well, we've got 2 y's here and another y here. So that gives us 3 y's. And then take a really close look at your problem and you'll discover that there's another one here that we didn't put in here. What happened to it? Well, we just always want to make sure we don't leave anything out. So we've got 4 more x's to add in. So let's do that. And now our final answer would be 12x, because we've got 8x and 4x, so we've got 12x and 3y. And you might be saying, well, why didn't you just do that all at one time? And I certainly could have. But what I just want you to know is that whatever your answer is, you always take another look at it and see if there's anything else you can do to make your answer more simple, to make it a more simple answer. If there's anything else that you can add together, you want to do that. It doesn't really matter which one of these two comes first. I put X simply because it was first in the alphabet, but it's not a real crucial matter. So our answer is 12x plus 3y. Now, I'm going to ask you something, and just answer this to yourself. Why can't we add 12x and 3y? Why can't we add 12x and 3y? And I bet what you said was, we can't add 12x and 3y because they're not alike. They're two different things. They're not like terms. So we can't add those. We can't add apples and oranges. We can't add x's and y's. So we have an answer like 12x plus 3y, then that is our answer. It just has 2 parts to it, and that's perfectly all right. It happens all the time. So that is our first lesson on how to add. And what if I were doing subtraction? Let's take a little bit of a look at subtraction because it's very little difference.